Okay, question 7 is going to be about gas pressure, collisions, and the pressure equals force over area. So we're going to go through all of that now. So we've got a metal container with a movable piston, so it just tells us that this can move up and down. Point X is on the surface of the container. Which of these shows the direction of the force? So we need to know that on any surface, the collision will be at right angles to the surface. So if it was a surface like that, it would be at right angles. So we're now looking for something where the particle is hitting or colliding with the wall. So definitely not going that way. And where it's at right angles. No, going the wrong way. Going the wrong way. Perfect. That is at right angles to the surface. So it's going to be C. On to the next one. The gas pressure is 120 kilopascals. We've got this is 2,500 centimeters cubed. That one's 600 centimeters cubed, and it just says calculate the pressure of the gas. So we know P1 times V1 equals P2 times V2, but ultimately, this is a nice question for foundation. It's to work out this, find the right things up there, put them in. So let's just quickly go through then. So pressure 1, it even tells that there, so that's going to be the 120. Volume 1, that's going to be 2,500, and it tells us to times the top part of this fraction. And then the new volume is 1,600. So we can see it's a really nice question where it's just asking you to find the information and write it down. And you'll be surprised at how many students will leave that blank. They'll look at it and just go, oh, I don't know what to do. So put in your values. 120 times 2,500 divided by 1,600, and we get our answer of 190 kilopascals. So my advice is when you get one like this, please don't panic. It's just read the question and see what bits do I need to put where. All right, but ultimately this is a rearrangement there of the gas pressure and volume equation, and we can see, well, P2, V2's got to come multiply both sides, divide both sides by V2. Okay, next one, we've got a bicycle pump with a closed end. We've got a piston. Again, this can move in and out. It says the area there, so the area of this piston is 2 centimeters squared. So there's the area is 2 centimeters squared. The force applied, so that force there is 28 newtons. Calculate the pressure, so we're going to need Professional Footballers Association, well, P equals F over A, and we just got to put those in. And we're just going to have a quick check. Does that match each of the components we got? Yeah, you're in newtons, you're in centimeters squared. Perfect. So that matches. So there's no unit changes. So P equals F over A, 28 over 2 equals 14 newtons per centimetre squared. Okay, next one, got 6 marker. So a container is sealed, so the mass of the gas cannot change. The volume of the gas is changed. So ultimately we're going from small volume to large volume to large volume, and it tells us we've got the same number of particles in here. We can see, well, this particle's got less distance, these particles got less distance to travel before they collide with the wall. These have got more distance to travel before they collide with the wall, and so on. And that's why as volume increases, the pressure or the gas pressure decreases. There's less collisions in this box here than there are in that one. So the crucial part is we're going to talk about particles, collisions. We're going to use our formula because it's that thing of every time. Go to the back of your booklet. So we're going to use our P equals F over A. And I'm just going to introduce you as well to the idea that, well, these particles that are moving, they have momentum. Delta P equals mass times velocity. So these particles have momentum. You know, they're a measure of how difficult it is to stop moving objects. They're going to collide with the wall. When they collide on the wall, they're going to produce a force. If I had the force divided by the area, I'm going to increase the pressure. So again, if we go from a small volume to a big volume, we've got the idea that these have got less distance to travel, but also that the force on each of the particles, because they're at the same temperature, so they're moving at the same speed, the force here is, so the pressure on that wall is the same force, but divided by a smaller area. So the pressure goes up. This one here has a huge area across there. So pressure equals force over area. And again, that goes with the idea as volume increases, pressure decreases. So we've got these two parts. The bits about the distance that the particles are moving and then how their force is over a larger area and the pressure goes down. So now we're just going to word all of that together, and I've highlighted the keywords to get in there. So we're going to use these two equations. Okay, so on to the first part. Gas particles are randomly moving inside the container. Gas particles have momentum, mass times velocity. As they collide, and we're going to have to get that word into our answer, with the walls of the container, they produce a force over an area. That's what gives us the pressure. Pressure equals force over area. And if I wanted to, I would then put this in. Pressure equals force over area. We've got some nice equations in here. Delta P equals mv. Next part. If the volume increases, the pressure decreases. We can see here, volume increasing, pressure decreasing. Next thing, talk about the graph. Is that a linear relationship or it's non-linear? Well, it's a curve, so it's a non-linear relationship. And in a greater volume, the gas particles need to travel further to collide with the walls. So we've got this idea of the distance that the particles need to go. And now we've got this last part in terms of the pressure equals the force over the area. And in a greater volume, so there are less collisions, so less force. And then the other part that we can have, again, is to just reinforce this part here. And I've not put that in there, only because it's up there as well. But now we're going to just put this in, and we've got an increase in the area. Pressure equals force over area. So if area increases, pressure decreases. And there we go. And that's a model answer for that 6 marker.